All right. So where we ended up at the end of the last video is we said if we need to add two vectors, they're kind of weird angles. We can do it by imagining one long trip where we start here and the first part of the trip ends here, but that's also where the second part of the trip starts and then it ends here. So overall, we're going from there to there. And we really would love to know what that resultant vector looks like. So you can imagine this kind of dotted red line being our resultant vector. But it's really hard to add these together. So the first thing we should do is break them down, just like we did over here. So we can take R1 and say, well, that's really like going R1 in the X direction and R1 in the Y direction. And if R2 in the X and R2 in the Y. So instead of a two-part trip, it's really a four-part trip. We said, well, that's kind of goofy. There's no reason to make all those turns. So instead of making all those turns, why don't we instead take these two X trips and do them right in a row? So R1 on X and then R2X. Because we can just kind of combine these two and say, how about R total X? Now add those two up. So let's say they're 4 and 8. And say, all right, in total, I'm going to go 12 meters in the X direction. And we can do the same thing in the Y direction. You have Y or R1Y and then R2Y. We add those up. So if this is 6 and 2, we can say, all right, in total, we went 8 meters in the Y direction. So we combine those together and call that RY total, or R total in the Y. Well, now our resultant vector is pretty easy to see. Again, we're just trying to make a triangle. And we start here and go up to the end. So here is R total. That's our result. Now all we do is the same thing we did here. We have a X, we have a Y. We can combine them using the Pythagorean theorem to get the total displacement from start to end. And then using some of our trig functions, we can get our angle. So that's a pretty simple vector addition problem. But suppose you had a more complicated one. So let's get rid of all this for one moment. What if instead of only having two vectors I had to add, what if we were to say add R1 and plus R2 plus R3 plus R4. Well, now there's a lot going on. And we certainly can line them all up tail to tip. So this is kind of a graphical way of adding up our vectors. But what we can do is if we know that eventually we're going to be forming this big triangle and putting all the X's in a line and all the Y's in a line, we can just do that mathematically without having to redraw everything. So what we can do is make a t-table with our X and Y values. And all we're going to do is use this original trig formula we had over here to get our X's and Y's from each vector. And we're going to say, hey, you know what? I need my R1X value. I need my R2X value, my R3X value, my R4X value. And if I add these all up, I'll have my R total in the X. Same thing with Y's. I want R1 for the Y, R2 for the Y, R3 for the Y, R4 for the Y, and then that gives you my R total for the Y's. Now, it's important to notice that some of these may be positive and negative. For R3, the Y value is actually down, so this is going to be a negative value. So I might go in here and just put a little note to myself. Likewise, I could just as easily have made R2 go backwards. So that would make R2 for the X direction a negative value. It also looks like R2 is only in the X direction. If that's the case, well, R2 in the Y direction is 0. I can take it out entirely. But either way, if I make my little t-table up, it's really easy to add those values and get my result. That result is going to give me that final triangle. R total in the X, R total in the Y, and that allows me to get my final resultant vector, R total. And then, of course, the angle. Again, using the same thing that we did over here. So it seems like these are complicated. This looks like a really hard problem, but there's really only two things that you need to understand. How to break down a vector into x and y components, because it's pretty easy to add and subtract x and y components. And then when you're done, we need to know how to recombine them. And that's it. That's vectors. Bye now.